Welcome to all to class number 30 of our course SFD and BMD. See, this class is the summary of relations and variations. This I told last class earlier. See, I derived all the relations and also variations in the earlier classes. Then I told next class I will put a summary, brief summary, so that in future if you want any reference you can come and refer this one. So remember, and I also will do same thing later. If any confusion comes, usually in this class you can't ask the doubt. Live class you can ask. I will tell class number 30. So I will mention later during SFD BMD, I will mention, see, class number 30 is your reference. Now, see, actually earlier if you remember, I first derived the variation, then I derived the relation. But now to understand, I will do one thing, I will start from here. See, first, relations, what all I will tell now. W is intensity of load. V is the shearing force. M is the bending moment. Now, see, usually what you do? You first draw loading diagram, below draw SFD, below draw BMD. I done same order here. But relation is reverse way. Means, if you want relation, see, dm by dx equal to shear force or dv by dx equal to W. Or you start from top, but start this way. Rate of change of shear force is intensity of load. Already explained thoroughly earlier. And rate of change of bending moment is shear force. I told earlier, so many places they use sign minus sign here. Don't use minus sign. In the basic derivation, you tell rate of change of shear force is intensity of load, rate of change of bending moment is shear force. The negative positive depends upon sign convention. I proved it last time only. Okay, now one more most important. Bending moment is maximum or minimum. Usually we get maximum, but once in a while we get minimum. As per mathematics, it is maximum or minimum where shear force 0. This is a basic. Reason simple. See, rate of change of bending moment is shear force. Like dy by dx is differentiation of y with respect to x. You know mathematics. What? Where for maximum or minimum y, dy by dx should be 0. Same way, for maximum or minimum bm, dm by dx, that is v, should be 0. But remember, the star means, I will tell you what is star. Late, this has got limitations. Sometimes this relation you cannot use. I will make it clear later when the time comes, not right now. I cannot go too much beyond the limit now. I will make it clear later. Star means subject to some conditions, mathematical conditions. I will tell, see, cantilever for example, when apply UDL like that, SFD will come, maybe, not maybe, it will come like this. BMD will come this way. So their maximum BM will come, where shear force also is maximum. It has got reason. So I will tell later what are the conditions. So time being, generally, and again, when this is valid, will be told later when you draw the diagram. It is much better. Remember, bending moment is maximum or minimum where SF is 0. But sometimes what happens is, SF will come this way. It will cross the baseline. Yes, you got 0 point. Sometimes SFD will come this way and suddenly cross at a point. Cross the baseline under a load. It happens under point load. Then it is, what is the shearing force there? I will give a special class for that one later, where majority of people are confused or give, I told earlier, some unrealistic answer. I will make full clear later. So later we will go for a modification. See, so what we will do is, BM is maximum or minimum where shear force 0 is the basic, which later will be slightly modified as BM is maximum or minimum where shear force diagram changes sign or shear force diagram crosses the baseline. See, where shear force diagram changes the sign, or you can tell shear force diagram sign of the shear force diagram changes or shear force diagram crosses the baseline. That all we will discuss later. I will, for each and everything, I will give the reason. For those who want to understand and learn, I will tell reason and technical reason. Sometimes there is a technical reason and logical reason both. I will tell everything for those who are interested. Okay, now, this is the relations now. So remember once again now, rate of change of shear force is intensity of load, rate of change of bending moment is shear force. I wrote here, bending moment is maximum or rarely minimum where shear force is 0, or you can tell where shearing force diagram crosses the baseline or where SFD suddenly changes sign. You can remember whatever way you want. Will be explained later. Now, come here. Second part, most important, variation of SF and BM. This is very important for drawing diagram. I will tell you why, reason now. See, I will first explain this one, then I will tell the most powerful, where I know majority, more than 90% have difficulty. I will clear everything when we have to actually draw the diagram. See, between two, I already told you, everything is between two standard points, successive standard points. Between two successive standard points, I told point load cannot come. I told the reason. Why reason? Once again, if between two standard points, successive standard point, if there is a point load, that point load also will become standard point. So there is no question of getting a point load between two successive standard point, and all our discussion will be between two successive standard point. Okay. Now, one case, no load. Between two standard point, there is no load. If there is no load, see once again, no load. Double is there because one of them is no load with no shear force. Shear force is not there. Then shear force is not there. See, blank. When there is no shear force, there is no question of variation. With zero shear force, then remember, bending moment will be constant or x power 0. I will tell what is the power. See, I written here that x power n means x power 0, x power 1, x power 2, that 0, 1, 2, 3, that is n. Means, if we consider section xx between two successive standard points, between two successive, I forgot right here, you can add here, between two successive, I forgot right here, successive standard points, I am already telling here. From x, at x from any reference point, that is not important. From some reference point, if you take distance x, then n is the maximum or highest power of x in the expression for SF or BM at xx. Suppose you take a section xx, and if you get by chance shear force, for example, is 25, means, see, there is no x there, x power 0, or you tell 25 into x, x highest power is 1. Suppose you get 25 into x minus 8x square, then not x, highest power 2, x square is there. Or BM, suppose you get 30 into x minus 45 into x, becomes what? Once again x only, highest power is x. Or 30x minus 50x square, yes, x power 2, highest power of x is 2. Or 75x minus 6x cube by 6, then x is not considered. See, that naturally 6 came. There's a reason is there. See, highest power is x power 3 there. So that is called that x power n. So that x power, what I wrote is, if you write expression for shear force or bending moment, in the expression, whatever x will be variable. Highest power of x is that n, x power n. See, between two successive points, this all explained earlier, we proved it. If there is no load and with zero shear force, means shear force first of all is 0, not there. BM variation is constant, and remember, this is called pure bending. This is called pure bending. So we will define later, pure bending is the bending where bending between 2 points, where in the absence of shear force or with zero shear force, it has got reason why that pure bending required. Later, when you go to deflection of beams or bending stresses, you will be knowing it. Okay, now, x, see, constant means x power 0. Suppose bending moment is 80. Yes, 80 means 80 into x power 0. X power 0 is 1. So, remember, no load with no shear force, Bm is constant. It will be parallel to baseline. See, you can write here. Constant means what else? It will be parallel to baseline. But no load, once again, general case. See here, no load with zero shear force. No load, general case. General case means what? That is, I won't write. General means shear force exists. Shear force is there. Then shear force variation, or I'll write here, general means shear force exists. Then shear force variation is x power 0 will come constant. See, when between 2 points, if there is no load, shear force, actually shear force is what? Resultant force from one side. So when there is no load between 2 points, as you move along that portion, wherever you go, when you look one side, loading will not change. So shear force will be constant, so x power 0, but bending moment will be linear. I proved it. Then UDL means between two standard points, successive standard point, if UDL is there, then shear force will be 1. See, as you come down here, power of x will increase by 1. As you go this way also, power will increase by 1. SF to BM if you go, SF is x power 0, BM is x power 1. See, don't see there. If SF is x power 1, if you go this way, BM is x square, highest power. If SF is x square, BM is x cube. Then come down for both of them. No load, this one you leave it now, come down. Whatever is the power of x for SF and PM both, as you come down, no load case, you got the power 0 and 1. UDL means 1 and 2. Means what? This way also it increases. X power 1, and that is x power 2 square. UVL, parabolic, second degree, x square, x cube. Means lastly I will tell now, between two successive standard points, if there is no load and no shear force, BM is constant, it will be parallel to baseline, it is called pure bending. That is a special case. Come down. Between two, once again, between two successive standard points, no load but shear force is there. If the shear force is there, then shear force will be constant, x power 0. BM variation is linear, x power 1. Come down. UDL. If UDL is there, shear force variation will be linear. So diagram will come this way or this way, straight line, linear, or it will be usually inclined line. Okay, then bending moment will be parabolic, second degree variation. Second degree, I wrote x square, highest power. If UVL is there, parabolic second degree for shear force, and parabolic third degree, sometimes people call cubic variation, x cube. So this correctly you go through. You can see a systematic pattern here. Follow the pattern. See, follow that pattern. For me, I don't require. I can, wherever I go, I can easily tell if someone will ask. If someone asks this way, I don't require from there. I don't have to start from this way. After practice, you can make out. See, no load, no shear force. Shear force is not there. No load, shear force is there, constant. UDL, shear force, linear. UVL, shear force, second degree parabola. Bending moment, no load with no shear force, BM constant. No load, but shear force is there, BM linear. UDL, BM, parabola second degree. And UVL, parabola third degree. So this correctly I remember. Now, the most important part where I have seen maximum people confusion, not maximum, so many people confusion will be when you get lean constant or lean constant means parallel to baseline. Okay, done, no problem. Linear means straight line. Straight line anybody can draw. Problem comes when it is UDL or UVL. For UDL bending moment, for UVL shear force and bending moment both. When it is higher degree, means what? X square or x cube, curvature will come. When curvature comes, what type of curve? See, I will tell you here. Suppose I want join this point to this point by curve. It may be 0 or may not be 0. Don't worry. See, I will put one by one now. Little space problem here. I will put here. Suppose I want join these two by a parabola, second degree or third degree later. See now, so many options are there. It may be like this, keeps on increasing, or it can be, see, like this, but when you reach here, it is almost, see, tangent will be making 0 slope here. Here slope is there, here slope is not there. Or it can be, who knows, it may go up and come down. Or sometimes, see, it may come, when I plot here, not this way, it may be this way. Or sometime, who knows, it may be this way and this way. See, it may go down and again come up. These are all based on the actually mathematical knowledge. How is the equation? But that is, if it is a mathematical equation, you have to think of mathematics there. But here, that is not required, because the relation of dv by dx equal to w, dm by dx equal to v will clear everything. When I draw the diagram later, when I draw simply support beam with UDL, sometimes some numerical partial UDL, cantilever, UVL all, at that time I will clarify each and every concept. I will tell you why the curve is like this, why it is the, why the curve is like this, why not like this. See, simple. Why the curve is like this, why not like this. I will give correct reason. It has got a perfect reasoning. So that all I will explain in the problems, not right now, because right now if I explain, some will comment. Already class 30, he told he will teach SFD BMD. Still not a single question is done for SFD BMD. People who want to learn and who see all these classes, they will realize what I am doing. I am creating a firm foundation for learning SF and BM. Okay, now next part will be, today I will close now. See, due to some problem, past 1 week I was very busy and heavy commitments were there for me. I could not upload classes. One more thing was, when I am free in the night time, it used to rain here. When it rains, disturbance will be there. So did not get a chance to make the recordings. That's why today I am doing daytime recording. Slight sound problem is there. Okay, adjust it. Now, further. Now the most critical part I will tell you is what? The explanation and understanding. If there is a point load is acting somewhere, then at that point, shear force you have to find twice. I will explain why. Whereas, if the couple is acting, then you have to find bending moment twice. And one more important, at the extreme end of the beam, there is only one calculation. So many people have seen, when they come to extreme end, they will tell once just this side, suppose the beam is this way. I have seen plenty of people. Shear, suppose A and B, suppose something. Shear force at A, just to left. That is completely meaningless. But what they tell is not wrong. But it is not the proper way of telling. I will make it clear. If wherever there is a point load at an interior point, shear force twice. Wherever there is a couple in the interior portion, bending moment twice. I will give the reason also. And extreme ends, it need not be support. Extreme ends, only one calculation, and that calculation is valid for which cross section. I will explain and make clear in class 31. And then what I will do is, in class 32, right from class 1 to class 31, what all important points were there told which are essential, I will write on the board before the class. I will not take much time. See, I will write all the point one by one here, correctly in order. I will mention class number there. I will just tell you, see here, this is the class so and so. So that you can take a screenshot of that one and preserve it. Later, suppose you get doubt, suddenly you can see the sheet, that screenshot there. You take a hard copy of that one. Oh, yes, I should go to class number 7. Yes, go to class number 7. So that class, complete brief explanation, but will not take more than 20-25 minutes, because writing part I will finish earlier. I will come and just tell you, see, these are the way you have to remember. Otherwise, usually I give in the paper to my class students. I give in a paper I write. Here I can't write a paper and give to you. So you can take screenshot, actually not screenshot. You can take screenshot and neatly make a note that I will tell you later. So right now, I will conclude now. This is the summary. Later, remember, I will not explain this one once again. This curvature type I will explain. Why curve is this way or curve is this way, or why curve goes up and then comes down, or goes down and comes up. That I will explain technically correct reason. Not only technically, I will explain an easy way also, so that all can understand. But these points again and again I cannot tell. All I will tell is refer to the chart or table given in class 30. Okay. Now, since I lost some 1 week time now, nearly little more than 1 week, I will do one thing now. Immediate next, not I told weekly 3 classes. By the time next weekend, I will upload at least 5-6 classes to balance whatever is the time lost here. Not time lost. I could not upload 2-3 classes this week. Last week also same thing happened. So therefore, I will upload more classes so that I will balance that one. So next class 31, I will tell that important concept of where shear force twice, where bending moment twice. I will tell you why also. And then further, extreme end. One more thing. See, if a couple comes this way, doubt comes. Shall I take positive or negative? I got a trick for that also. To avoid confusion, for everything where there is a confusion, I have a trick. I will tell you. Maybe sometimes it may look little crude. No problem. Sometimes crude method, see, bending moment I told earlier, plus, minus. Those who correctly concentrate, they will not tell crude. So my students will tell, sir, it is not crude, sir. It will help us a lot. But now, after practicing, they get the idea. They will tell sagging, hogging. They won't tell this way. I will tell why you are turning your neck. So now they will tell, yes, got it, sir. Sagging, hogging. See, sagging, hogging. All I will make clear. Therefore, go through the class repeatedly. This one correctly understand and be ready for next class. 31 is for that special case. 32 is for summary. 33, good number. First example for SFD BMD. Okay, thank you.